Hello, I'm Kirk Weiler, and this is Common Core Algebra 2 by eMathInstruction. Today we'll be doing Unit 11, Lesson number 11, on the reciprocal functions. Alright, so far we've looked at the sine function, the cosine function, and the tangent function. But there are actually 3 more trig functions. Alright, and all of these are defined in terms of the original 3, which can then actually be defined in terms of just sine and cosine. All right, let's jump into them and get a little work with them in this lesson. All right, so the 3 reciprocal trig functions are known as the secant, the cosecant, and the cotangent. The secant function is simply defined as following. The secant of an angle is 1 divided by the cosine of the angle. And the cosecant is defined as the cosecant of an angle is 1 divided by the sine of the angle. Now let me just point out, for the record, how irritating it is that secant is 1 divided by cosine, but cosecant is 1 divided by sine. Those are really, really irritating. It'd be great if secant was 1 divided by sine and cosecant was 1 divided by cosine, but it's not the way that they turned out geometrically or algebraically. Cotangent is easy enough. It's 1 divided by tangent, but it is normally thought more commonly as cosine divided by sine. Remember, tangent is sine divided by cosine, so cotangent is cosine divided by sine. All right, in this course, we want you to just get a little bit exposure to these 3. You'll surely work with them more in whatever 4th year math course you take or in college level mathematics. So let's jump right into it. One of the things we want to be able to do is evaluate the sine and the cosine. We want to be able to evaluate these 3 functions at any of the special angles given the unit circle. Now, this isn't too bad. The secant of 60 degrees, by definition, is 1 divided by the cosine of 60 degrees. That's just what it is. Now, the cosine of 60 degrees is the x-coordinate at 60 degrees, which is 1/2. Now, as always, this is a complex fraction, so we could multiply the top and the bottom by 2. Here, those 2's would cancel, and we just find that the secant of 60 degrees is 2. All right? So that's not too hard. Why don't you go ahead and try to do the cotangent of 150 degrees? Well, we could think about it as 1 divided by the tangent of 150, but it's probably most helpful to think about it as the cosine of 150 divided by the sine of 150. All right, the cosine of 150 is negative root 3 divided by 2, and the sine of 150 is positive 1/2. So again, simplifying that complex fraction as we often do by multiplying the top and the bottom by 2, and we find the cotangent of 150 degrees is negative root 3. Now in part C, we have the cosecant of 3 pi over 4 radians. If you know what that corresponds to in terms of your degree measurements, great. If not, perhaps you come over here and you say, I have 3 pi over 4 radians. Maybe I'll convert that into degrees. 180 degrees divided by pi radians. The radians would cancel. The pi's would cancel. 4 goes into 180 45 times, and that is 135 degrees. So cosecant of 3 pi over 4 is the same as the cosecant of 135 degrees. That's going to be 1 divided by the sine of 135 degrees, which is going to be 1 divided by root 2 over 2. Now we can simplify this by getting rid of the complex fraction, and that will give us 2 divided by root 2. Some teachers and some tests consider that simplified. We've talked about this before. Some ask you to do what's called rationalizing the denominator. Now in this case, that turns out kind of nice. If I multiply both top and bottom by root 2 over 2, we get 2 root 2. Root 2 times root 2 is 2. And then those cancel. So really, this is a very nice way of stating the cosecant of 3 pi over 4, just as the square root of 2. But in my mind, either one of those are acceptable. All right, pause the video for a minute and write down anything you need to. Okay, let's clear out the text. Now exercise 2. Which of the following is closest to the value of secant of 52 degrees? This may seem like a strange question to you, kind of like, well, geez, man, I mean, what? This seems really easy or really hard, depending on how you look at it. 52 degrees isn't one of those special angles on the unit circle. But why not just plug this into the calculator? Take a look at your calculator for a minute. What you might notice is that there's no secant button on it. It always boggles my mind on these, TI calculators or other ones, how many different things they have on them, and yet they don't have secant, cosecant, or cotangent. Somebody should get onto that. And yet, no problem, right? We know that the secant of 52 degrees is the same as 1 divided by the cosine of 52 degrees. All right, so try that on your calculator. Okay, did you get 1.62 rounded to the nearest hundredth? If you didn't, it means you're probably in radian mode. And I wouldn't be surprised if you're in radian mode. I mean, what have we been doing? For the last, many, many lessons, we've been graphing sine and cosine, and we did that all in radian mode. If you didn't get 1.62, pause the video, pop back into your calculator, put your calculator in degree mode, and try it again. Okay, well, hopefully you got it this time. Hopefully you got it the first time. But it's very easy with this mode business to not get it right. I'm going to clear this out. All right. Now, all of the reciprocal functions, cosecant, secant, and cotangent, they all have variable denominators, which means there's a chance that we could end up dividing by 0 in them. So exercise 3 says, which of the following values of x is not in the domain of cosecant x? In other words, which of these values of x, if I try to plug it in there, will make cosecant not exist, does not exist? Well, let's take a look at something. Cosecant of x is 1 divided by sine of x. Okay, and sine of x is the y-coordinate on the unit circle. So the question is, which one of those angles has a y-coordinate of 0 on the unit circle? Think about it for a moment. All right, well, hopefully you chose choice 1. Right? If I do a real quick and not great job of sketching the unit circle, 180 degrees is right here at the point -1, 0. The sine of 180 degrees is 0, and therefore the cosecant would be undefined, and therefore x equals 180 would not be in the domain. That's easy enough. Pause the video now, write down anything you need to. Okay, let's clear out the text. And let's go to the back side of the sheet. All right, now kind of like what we did earlier on in this unit, I'd like to determine whether or not cotangent, secant, cosecant, all that stuff is positive or negative based on the quadrants. Okay? So let's think about cotangent of beta in quadrant 2, right? So remember, unit circle, quadrant 1, quadrant 2, quadrant 3, quadrant 4. So if I have an angle that terminates in the second quadrant, will cotangent be positive or negative? Well, let's play around with that. The cotangent of beta will be the cosine of beta divided by the sine of beta. Well, in the second quadrant, the x-coordinate is negative, and that's cosine. But the y-coordinate is positive, that sign. And a negative divided by a positive is a negative. So cotangent of beta is negative for any angles in the second quadrant. Those would be angles in degrees between 90 and 180, and of course many other angles depending on coterminality. Ooh, that was a cool word, coterminality. I don't even know if it's a real word. Anyway, letter B and letter C ask us about secant and cosecant. Pause the video now and think about these two. All right. Let's take a look. Secant beta will be 1 divided by the cosine of beta. If we're in quadrant 4, right, then the cosine is a positive number because it's the x-coordinate. So we have 1 divided by a positive number, but 1's a positive number, so a positive divided by a positive is a positive. In fact, what that means is that secant always has the same sign as cosine. Because really, the difference between them is that they're reciprocals. They're just flipped fractions. So if a fraction is positive, when you flip it, when you find its reciprocal, it's still positive. And if it starts off as negative and you flip it, you find its reciprocal, it's still negative, right? If I start off with cosine being negative 1/2, secant is negative 2, etc. All right, I think I gave the farm away for letter C. Let's take a look at it. Cosecant of beta will be 1 over the sine of beta. And in the third quadrant, I keep going back to this picture, since the y-coordinate is negative, and we have a positive divided by a negative, cosecant of beta will be negative. And just like over here, cosecant, actually let me write it all the way out, cosecant will have the same sign, this sign, the same sign as sine, that one. All right? And this is important to understand for a variety of different applications involving trig, some of which we'll get to this year, some of which we'll have to wait until further study. Pause the video now and write down anything you need to. Okay, clearing it out. Exercise 5. If cotangent of theta is less than 0 and secant of theta is greater than 0, then theta could be which of the following angles? Well, pause the video and think about this. Somehow this relates to the last problem that we did. All right, well, let's think about this for a second. Cotangent of theta will be cosine theta divided by sine theta. And we're being told it's less than 0. So that means it's either this scenario or it's this scenario, right? Either way, we're going to get a negative out of this. All right. On the other hand, secant theta, which is 1 over sine theta,
oh my gosh!
well,
no
that's
way!
greater than 0. So that's got to be this deal. All right. That means sine has to be positive. So we've got to be in this scenario. We've got to be in a scenario where the sine is positive, and remember that's the y-coordinate, and the cosine is negative. Remember, that's the x-coordinate. So then the question becomes, where or in what quadrant are we in where the y-coordinate is positive, but the x-coordinate is negative? That's got to be quadrant 2. And what angle, which one of these is a quadrant 2 angle? Well, that's choice 3. All right? It's kind of cool. Pause the video now, write down anything you need to. It's really kind of amazing how much of this work relies on your basic understanding of fractions and signed number division. right? You know, a positive divided by a positive is a positive, etc. All right, let's take a look at exercise 6. It says, a right triangle is shown below with sides of lengths A and B. Find the length of the hypotenuse in terms of A and B. Label it on the diagram. In other words, yeah, okay, I'll call it C, but what is C equal to? Well, we know that A squared plus B squared is equal to C squared. So if we solve for C, we take the square root of both sides, and that gives me C is the square root of A squared plus B squared. And that's where you want to stop. Do not distribute that square root. Don't tell me that C is A plus B. That violates the triangle inequality from last year, so don't do it. Now what we're going to do is we're going to write out every one of those ratios in terms of the constants A and B. So what I'd like you to do is take a shot at this right now. All right, well, we're going to do some right triangle trig first. Sine of A is opposite over hypotenuse. The side opposite of A is little a, and the hypotenuse is the square root of A squared plus B squared. Cosine is adjacent over hypotenuse. I should have given myself a little bit more room here. Adjacent over hypotenuse, which is going to be B divided by A squared plus B squared. The tangent of A, well, that's going to be opposite divided by adjacent, and that turns out to be the simplest of them all, A divided by B. Now, what's cool is that all of these are called the reciprocal functions for a reason. This cosecant of A is 1 divided by the sine of A, and we could, write that down here, but the whole point of reciprocals of 1 divided by is that it flips the fraction. So cosecant of A is square root of A squared plus B squared divided by A. Secant of A, which will be 1 divided by the cosine of A, will be the square root of A squared plus B squared, divided by B. And finally, the cotangent of A, this is one place where it's nice to know it's 1 divided by tangent, is going to be B divided by A. All right, so pause the video now and write down anything here that you need to. Okay, let's clear out the text, do one last problem, and finish up our unit on trigonometry. All right, last problem. If alpha is an angle whose terminal ray lies in the 4th quadrant, that's important, and cosine of alpha is 1/3, determine the exact value of cosecant alpha. Show how you arrived at your answer. All right, the first thing that you want to do in this problem, actually, let me pause. This is the last problem we're going to do in trigonometry. You pause the video and take a shot at it. Okay, let's go through it. The first thing that I want you to do in a problem like this, or that I think you should do in a problem like this, is to write out something very strange. Cosecant alpha, that's odd, is 1 over the sine of alpha. All right? Now, what that immediately tells me is I need the value of sine alpha. I know the value of cosine alpha. As usual, in this case, what we do is we use the Pythagorean identity, cosine squared plus sine squared is equal to 1. So I'll get 1/3 squared plus sine alpha squared is equal to 1. That'll be 1/9 plus sine alpha squared equals 1. Subtract 1/9 from both sides. And I'll get sine alpha squared is equal to 8/9. Take the square root of both sides, and I'll get sine alpha is equal to plus or minus the square root of 8/9. Now remember, square roots can distribute over division. So I'll leave the square root of 8 as the square root of 8, but I'll make the square root of 9 into 3. Now it's got to be either plus or minus. Which one is it? Well, we're in the 4th quadrant, and in the 4th quadrant, the sine of any angle is negative, right? Fourth quadrant, down here, sine's the y coordinate, y is negative. So sine of alpha is actually negative root 8 divided by 3, which means the cosecant of alpha, which is its reciprocal, is negative 3 divided by the square root of 8. Now, that's the exact value. I'm very, very comfortable with that. There's lots of different ways, though, that you could write this. And again, I want to emphasize this in case your teacher would want you to do this. You could rationalize. All right, so this would be one way to leave your answer as well. And we could even simplify the square root of 8. Oh my goodness, as 2 times root 2. And then we could divide that out, and we'd get negative 3 root 2 over 4. So there are certainly plenty of math teachers that would consider this to be the simplest form. Now notice this question didn't actually say give its exact answer in simplest form, but some of your teachers might say always put it in simplest form. So that's one option. All right, pause the video now and write down anything you need to. Okay, clearing out the text. Let's wrap it up. So there are actually 6 trig functions. In order of importance, number 1 is sine, number 2 is cosine, and they're a close 1-2. Tangent's definitely very important, especially for right triangle trig, less important for trigonometric modeling, but it's still definitely number 3. The last 3, secant, cosecant, and cotangent, are much less important, but they do get used in some higher level math, so it's good to get an initial exposure at the Algebra 2 level. All right, well, I'd like to thank you for joining me for another Common Core Algebra 2 lesson by eMathInstruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.